Hello everyone again, and welcome to our video. Today we are going to be looking at impulse. Alright, this is the final section in the momentum and impulse section of mechanics. Alright, now first of all we define what impulse is. Alright, impulse is the product of the net force and the time interval for which the force acts. Alright, so the formula for impulse, if we had to write it down, would be the product of the net force, F net, multiplied by delta T. Alright, and that is equal to our impulse formula. Alright, so that is impulse. Alright, however, from Newton's second law, what do we know? We know that F net is equal to the change in momentum over the change in time, delta P over delta T. Now we remember this, right, from previous videos, that the net force is equal to the change of momentum over the change in time. So when working out the impulse formula, alright, all we do, we know that this F net is equal to the change momentum over the change in time, right? That's F net. Right, or the net force. Okay, so in order to get impulse, all right, in order to get this whole formula, all right, we have to multiply by delta T on this side to get rid of it, and multiply this side as well by delta T. So we get, however, delta P is equal to F net multiplied by time. So let's fix that. Alright, now look at this. Change in momentum is equal to F net times the change in time, or multiplied by the change in time. Alright, so therefore we can define impulse momentum theorem as impulse is equal to the change in momentum. Alright, so this whole thing over here, alright, is impulse. Alright, so the way we work out impulse, alright, as the change in momentum is taking the net force, alright, multiplied by the change in time, and that gives us our impulse. Alright, so let's have a look, alright, through an example how we can calculate impulse and how we can actually understand an impulse question. Alright, so in this video, I'm going to show you how to answer an impulse and change in momentum question, as well as calculating impulse from a graph. Okay, so let's start with worked example 15, taken directly from the Ciabola textbook. All right. Question. A 150 Newton resultant force acts on a 300 kilogram trailer. Calculate how long it takes this force to change the trailer's velocity from 2 meters per second to 6 meters per second in the same direction. Assume that the force acts to the right, which is the direction of motion of the trailer. So, step 1, of course, with every question, identify what is given and what is asked. So what are we given in the question? Well, we are given the trailer's mass of 300 kilograms, the trailer's initial velocity, which is 2 meters per second to the right, as well as the trailer's final velocity, which is 6 meters per second to the right, and the resulting force acting on the object, which is 150 newtons. And what are we asked for? We are asked to calculate the time, delta T, taken to accelerate the trailer from 2 meters per second to 6 meters per second from the Newton's second law. All right. Well, using the impulse formula, all right, let's just let's clear the page here. All right, so we know that change in momentum is equal to F net times delta T. And we know the change in momentum, all right, from the graph, or from the formula, excuse me, is obviously the mass times final velocity minus mass times initial velocity. All right, so mvf minus mvi for the change in momentum equals f net delta t. All right, because this is what the change in momentum is equal to. We remember that from previous videos. All right, so all right, we have our formula. Now to rearrange the formula so we have delta t as the subject of our formula, all right, we have a straightforward formula to work with. All right, we just divide everything by f net. So we're going to divide this side by f net to get rid of it. So we only have delta t left. All right, and we're going to also divide this side by f net. All right, and we get our official formula that we're going to work with. Delta t is equal to mvf minus, excuse me, that's mvi. All right, let's fix that there. mvi, let's bracket that all over f net. All right, there we go. I'm writing it like this. All right, the example, they take out m as a common factor and write m over f net brackets vf minus vi. So now that we have everything we need to find delta t, let's go ahead and find that. So we choose our frame of reference first in step 2, and we know we are choosing right as the positive direction, as both initial and final velocity are going in the right direction, which is perfect. All right, and then we do the calculation in step 3, and then we also quote the final answer. We sub in our values. All right, we know this. All right, I'll just sub them in here for you on the board as well. All right, I'll sub them in here so I know delta t. All right, let's just draw a line down here. All right, there we go. Delta t is equal to, the mass was 300. All right, I'll take it out as a common factor as well. And we had our 6 minus our 2. All right, all over f net, which was positive 150. All right, and that should give us an answer. Therefore, delta t, all right, if we put that on our calculator, delta t is equal to 8 seconds. All right, 8 seconds. All right, so if we have to quote our final answer, it takes 8 seconds for the force to change the object's velocity from 2 meters per second to the right to 6 meters per second to the right. All right, and that is our final answer. It takes 8 seconds, right? That is the time for the force to change the object's velocity. All right, because remember the object's velocity in the question went from 2 meters per second, all right, to 6 meters per second in the same direction. All right, perfect. We can also say in the same direction, or we could state it as the question has stated it there for us, to the right. We can actually specify the direction if we so choose to. All right. Thank you everyone for tuning into this video. In the next video, I will be demonstrating how to calculate impulse from a force graph.